Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Let's continue our graded classwork about refraction of light. We have now question 8. Array of monochromatic, and we said before mono means one or single and chromatic means color. Okay, so it passes through a glass prism, and the first part is asking you to state what's meant by the term monochromatic. So monochromatic means light of single wavelength or frequency, or single frequency. Okay, state the name given to what happens to the ray at A. Where's point A? So we have here A. Okay, we have here point A. So at A, what happens? The ray is refracted. So here, what happens at A when the light ray travels from air to glass at this boundary? The ray is refracted towards the normal, and this is the angle of refraction. And we have here, this is the refracted ray. So what happens at A? Refraction. Use the values on the diagram to calculate the angle of refraction at A. Okay, your mathematical skills. You have here, this angle is 90. The interior angle of the triangle add up to 180. So this angle is 180 minus 90 plus 61. So 180 minus 151, the answer is 29 degrees. So you have to write in the space here 29 degrees. Calculate the refractive index of glass. Once you know angle of refraction and you have already the angle of incidence, it's very simple to apply Snell's law. Since you have here the angle of incidence in air, so you can use the simplest form of Snell's law, which is sine angle in air over sine angle in the glass. So you have sine 45 divided by sine 29. So the answer is 1.458. Okay, again guys, the refractive index, it has no unit because it's a ratio between two similar quantities. Okay, you can write the answer to here you have n is equal to 1.458. Okay, so you can write your answer to two significant or three significant figures, and you have the final answer. Only the final, your final answer should be rounded, but I prefer, if you have refractive index, you have to keep the answer like this, because the difference between two materials, their refractive index is very, very small. So you can find a material, its refractive index 1.45, the other one 1.48, for example. So if you are calculating refractive index, no need to round your final answer. Okay, Okay, back to our question. Part E. Explain why the ray doesn't emerge into air at B, but it does emerge at C. Back to the diagram here. We have B and we have C. Here, total internal reflection takes place. Why? Because angle of incidence is greater than the critical angle. So 61 is greater than the critical angle. When it emerges here in air, angle of incidence is less than the critical angle, so it will be refracted. So we will write here that at B, what happens? I will write in symbols because we can write all of it. Angle of incidence is greater than critical angle. The ray is totally internal reflected in glass. Okay, but at C, angle of incidence is less than critical angle. The light ray is refracted and emerges into air. Is it clear? The next part is very important. It's challenging. Okay, on the figure here, draw the path of the ray after it has reached B and until it has passed again into air. Okay, using the ruler. Okay, the tricky part here that you have boundary, because you have here transparent adhesive to identical prism and they have the same refractive index. Okay, so now we don't have different media, so you can consider it refraction. No, you have here glass and you have here glass. So here glass and here we have glass. So the light ray will continue in the same direction without any bending, without any refraction. So it will continue in this direction. Okay? Okay, here it's a new boundary between glass and air. It's a new boundary between glass and air. So as usual, we have to draw normal, which is perpendicular to the boundary. Okay, so as light ray travels from glass to air, as usual, it bends away from the normal. So here it bends away from the normal. So it bends away from the normal. So it will not continue in this direction. It will bend like this, somehow parallel to this one, this incident. It will be parallel to this one, as if it's like the rectangular glass block.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics blender.